I'll give the radius and the reduced radius for the internal.
Yep.
And explain all that. And then I'll get to the stage of saying 12, 3 o'clock and all that, and then I might call you in to do the
Fantastic.
the diameter times pi.
Okay.
And you can work it through there.
All right, great answer.
All right.
Yep, thanks.
Yeah.
No worries.
Gordon, what I was thinking is if I give the boys one of these each,
Yeah.
then they can start throwing them at me and I can actually write things on the board.
Sure.
Maybe
Nice.
that might work better. Save me
Definitely.
keep it looking down, because you know, so you just go forget what you've got to say.
Sure.
So yeah, I might just do that.
Yeah, so you can run some copies?
Yeah, what do we need? 2, 4, 6, 8, 10, 12. Yep, no worries. Good morning, fellas. Today we're going to look at commercial tiling and sort of weigh it up and versus the residential aspect of tiling, and we're going to look at all the points of how different it really is, how all the planning, all the procedures, details, specifications, all that sort of stuff that really needs to be considered before the work can actually be started. This sort of diagram that we have here is pretty much a tessellated border all the way around the perimeter, as you can see, with a strip border which is going to be cut from the same size tiles, and preferably we're going to use 2 tiles to sort of give us a bit of contrast and colour, more for aesthetic purposes than anything else. The base size is going to be roughly about 7.340, but we're going to double check in the workshop, and a width of about 350, probably about 22 square metres of tiles overall. And then we need to cut those triangles to link up with a 200mm span once again. So we're going to have a 200 by 200 tile, for instance, and we want to cut these triangles out. So if we use 200mm divided by 1.4, fellas, who's got a calculator?
I've got a calculator.
Thanks, Brent. Could you work out 200 divided by 1.4?
142.8.
So we've got 142.8 millimetres. So that tells us that if we cut our tile 142.8 millimetres up the square side, and we put a diagonal cut through there, that'll give us a total span of 200 millimetres. That 200mm span that we've got through there, we're going to need that to link up with our triangles and our 50mm between the strip border, internal, external strip border at 50mm, and our tessellated work will be in between that, running around all the perimeter of the work, as you can see on the board. Gordon, could I just get you to maybe perhaps work through that with them?
Certainly, Enzo. Guys, this is a nice, simple formula that you can use, and you probably will use quite often, particularly in this type of work where you're cutting a lot of diagonals, triangular tiles. You can use it as Enzo suggested there, whereby you've taken the diagonal measurement that you need and divided it by the 1.4, which gives you, as Enzo said, that distance, which you can quite easily measure along both edges of your square tile. And then by marking the line, you'll find that you've got the required diagonal. Enzo, did you want to mention something along the lines of the cutting of that diagonal?
Yeah, all the guys would be fairly familiar with their Sigma tile cutters, which has the swivel bar, which gets turned around obviously, and it's set at a 45-degree angle, so it automatically produces the angle that's required. And having worked that calculation there out, it means that you can just simply, on the tile cutter, which has all the millimetres indicated, and then obviously the centimetres, they can actually run the tile down to 142 millimetres, 0.8, and that'll give them the produced angle that's required, and at the same time the measurement that's required. So it's a one-step process which makes it really easy these days with the swivel bar tile cutters.
does anyone want to ask any more questions regarding the cutting of this tile or the formula?
I was just wondering if that the formula for cutting of the angle, does that stay constant, or is it always the same depending on the tile size, or does that change?
It does stay constant, Reece. As long as you've got your 90-degree angle in the bottom of your corner there, in the bottom of your tile, and you work from that 90 in both directions, your formula will stay constant. You can use that 1.4 right up to an enormous angle, a huge tile, right down to a very tiny tile.
Like say 600 by 600 vitrified or something like that.
Yes.
Should it still be used? As long as, is it because the tile's square, or?
Well, basically what you've got is a relationship between your length of your side of your square to the actual diagonal, and that relationship remains constant.
Yeah.
Guys, I've got a few examples here that I want to show you and discuss with you along the lines of the diagonals that Enzo and I have been both talking to you about. Don't forget here, we're using a formula whereby you're going to, first of all, take the diagonal that you require, diagonal required, in this case 202 millimetres. Okay, from that I want you to divide that 202 millimetres by 1.4. Okay, in this case we've got, don't forget your decimal point, fellas. It does make quite a bit of difference. And you'll use that on both numbers too, I might add. Okay, now in this particular case here, we want a diagonal required is 202 millimetres. Let's say there it is right there. That needs to be 202 millimetres. I've taken my 202 millimetre required diagonal, divided it by 1.4, and I've come up with 144 millimetres. Now, that simply means that if I go to the corner of my tile, corner of my square, measure up in that direction, 144 millimetres. Once again, same here, 144 millimetres. Mark it at that point, draw my diagonal through. My diagonal will be 202 millimetres long, and that's it.
What type of tiles would you use in an area like that where there'd be a lot of people going through?
Anthony, tiles are manufactured for different intended use on the tiles. You'll have your residential, commercial and industrial. Obviously industrial would be extra heavy duty surface on the actual tiles. So you need a tile that's actually, which is classified from group 1 to 5. You'd have to be up there at the group 5 plus. All right? A tile that's actually made to cope with heavy loads, extreme traffic. If we use residential tiles in a commercial area, in an industrial area, the glazing wouldn't last probably 12 to 18 months. You'd start to get wear over the whole entire floor area.
Enzo, just a question that's I've just thought of. With all the cutting that's involved with such an intricate job here, using the more heavy-duty industrial or commercial tiles, is it going to affect the difficulty of cutting?
It's just going to mean a lot more pressure on the actual tile cutter itself as they strike and scribe the tiles. But generally speaking, they cut reasonably well. Some of the real heavy industrial tiles may sometimes require diamond saws to be used through, especially on some of the diagonal cutting. You can get a few difficult tiles that might not, cut as quite as easy as we'd like to. But generally speaking, it's not a major problem. We tend to get through that situation quite well, really. Once we've got the tiles laid out on our little template, which we're going to use cement sheeting or gyprock, whatever's available out in the workshop, that'll be our building board that we're going to lay our tiles out on, and we have to make sure we've got a perfectly square grid. So if we're going to have 915 millimetres across there with our spaces, which we'll check in the workshop when we're doing it, we need a 915 that way, 915 that way, 915 that way. So it's got to be perfectly square and perfectly parallel to have a perfect set out. We're going to set a radius of 360 millimetres to run right through to the outer circumference, or the edge of the circumference there. Once we've done the complete circle at 360 millimetre radius, we're going to have two perfectly circular circles running
this case.
parallel to one another. We've got the two circles drawn up with those radius that we've already talked about. Then we get to the stage where we need to work out our segments, the little pieces in there. And Gordon, if you'd like to go through that with the guys.
Okay guys, let's look at the formula that we're going to use to calculate our tile sizes. First of all, you've all got your formula sheets in front of you, so if you want to just take those out and just look up that formula that you will be using. As you do that, I'll just write it up on the board for you. Okay, guys, letters, symbols signify exactly what the words are we're going to use. As you all know, D for diameter, which is your line passing straight through the centre of your circle from side to side. Now don't forget, we will be using the measurements of the outside circle. Pi, as you all know, 3.14 is good to use, and as always remains the same for every circle calculation that you'll be doing. And C for circumference, all right? So guys, let's apply this formula to your actual project, all right? We've got our diameter here from side to side, which is going to be 2 times our radius. So 2 360s will give us exactly 720 mils. All right, times, as our formula states, times our pi will equal, I'll just quickly do that on the calculator. Great, okay, 2.261. Okay guys, if you were to take that circle, that outer circumference there, stretch it out into a straight line, a string, a measuring tape, whatever you wish, it will be 2.261 metres long. Okay, that's our circumference. Now, from there, as you can see by the diagram, and as I'm sure many of you know from doing these projects previously, you will work with a quarter of the circle first, for obvious reasons. Once you've worked out, calculated and cut tiles for 1/4 of a circle, you're really reproducing that same project or that same task 4 times for an end result. Okay, so let's go our full circumference, 2.261. Now, divide that by 4. And we come up with 565 millimetres. Okay guys, this point on the circle, all the way around to this point, which represents 1/4 of our circle, is 565 mils. From there, let's divide that by the number of tiles that we wish to use. Now in this case it's 15. Okay. And that's 37.6, which represents the measurement of the outside of each individual tile. Guys, don't forget, when you measure, when you formulate and when you do these calculations and formulate the size of each one of these individual tiles, don't forget that you're going to require a 2 millimetre gap between each tile, which obviously will be graded later. Now, that'll simply come off your measurement here, and you'll allow for that when you're doing your cuts.
How would you go about cutting the circle out of the full tiles?
Brent, that's obviously circular cutting on a bigger scale than we normally would do on a typical bathroom or wet area, where we're just cutting a small circular around a floor waste, an outlet that goes outside for plumbing purposes. This is just going to be on a really big scale. So we're still going to use tile cutters to remove, you know, the majority, or the major part of the tile, the biggest part of the tile I should say, and then we're actually going to use our round jaw nippers to get a circular shape. And we all know how accurate you can be if you take the time and you've got a nice sharp pair of nippers. We can achieve a beautiful contoured circular shape cut, and then we're just going to sand it down with a bit of sandpaper to give it a nice safety edge and nice and smooth. And that's pretty much all there's really involved, and it's not quite as hard as it may seem. Ask them what the formula is before you write it up on the board.
Definitely, definitely, and so I'll do that.
Okay.
Yeah.
Probably going to do it anyway, so yeah.
Yeah, well, yeah, I do
Yeah.
like to ask them that.
Yep. I guess we probably might move on to the inlay and or the segmented pieces,
Yeah.
which perhaps you can explain and go through all that.
Yeah, I'm going to go over it pretty quickly, Enzo. And if you want to dive in on that 1 millimetre.
Yeah, I will. Yeah, I will. I'll come in on that one for sure. We've established we're going to need 60, just on obviously experience, on a circle that has a diameter of 720 millimetres. All those will radiate back to the centre, as you can see there from the diagram that Gordon's prepared. They'll all radiate back to the centre, and by having that effect there, it means that the tile will be slightly wider there than it is there. The only thing is we need to remove 2 millimetres on either side of the segment to leave us a joint space, don't we? Because we've got to be consistent with all our joint spaces through all the body of the tiles there.
Well, if you have to leave 45 on the top and bottom, how have you actually worked out to leave the joints between, or 15?
Well, good question, Mark. I'll just finish that one there off first. So if we take 2 millimetres at each end, it'll give us a balance of 41 millimetres. That's the size we're going to cut our strip. And to answer your question, Mark, once we put our tile across there in a strip that we've cut, we're simply just going to reduce back 1 millimetre either side of the line, and the next piece will be cut back 1 millimetre back off the line, and that'll give us our 2 millimetre space that we need. So our work will be consistent all the way through.
Does anyone have any questions along the lines of the formula that we used, or working out the quadrant or anything like that?
Will you be putting in an expansion joint because it's a commercial floor and the traffic over it and such?
We will be putting a expansion. If we can just slip back to this one here for a moment. Does anyone remember or know what our span in terms of regulations for expansion joints is?
3 metres.
3 metres? For external work, 3 metres is okay. But generally speaking, we're really talking about a 5 by 5 metre grid. All it has is that relief area. As tiles expand, the stresses can be relieved into the flexible filler material.
And where on that floor would you lay the expansion joint?
Generally speaking, you'd like to not to coincide with your inlay, because this actual span, as we said before, is about 7.345 or thereabouts. We're just going to put one which will break it down below that barrier there of 5 by 5 lineal metres of floor space. Does that make sense? Yep.
What we've got here is exactly what we had on the board this morning that we were discussing. You've got your full circle, your outer circle, and your inner circle. If I'm not mistaken, we have a 720 millimetre diameter here. Using the formula that we spoke of this morning, multiplying our diameter by pi, we'll end up with a circumference. Now, does anyone remember the circumference that we came up with this morning of this outer circle?
720.
720, that was our diameter, yes, that's right. But we multiplied it by our pi, 720 by 3.14.
565. That's it.
So we were well and truly over 2 metres as a circumference. So if you lay this line out, from there we divided that by 4 to simply give us our quadrant, which is 1/4 of a circle, or 12 o'clock to 3 o'clock. And we then divided that by 15. We then divided that measurement of 1/4 of our circumference by 15. Okay, that gave us an individual piece from those points. Once you've got a nice equal number of 15 points within your quadrant on your outer circumference, you can then bring those all into the centre. And that obviously then gives you the inside measurement on your tile piece as it crosses the inner circumference.
What happens if the 15 pieces don't fit?
Okay, good question. If you start, once you've divided your quadrant into 15 pieces and you've come up with a 37.8 mil, you've set your scribe and you're going to work your way around here to evenly get each piece. If you end up at 3 o'clock here with an extra 8 or 10 mil over, if you're working with 15 pieces, obviously you're going to have to open up each piece by about a mil, and that'll compensate for that 15 mil over the whole distance.
Do you take it off each tile, or do you start again at a smaller?
You would start again, yeah. So let's, yeah.
Using the calipers.
Using the calipers, exactly. Readjust your calipers.
Position the tile of the outer circumference and the inner circumference. Just mark your tile off, allowing for your 2 mil joint. Thanks, Reese. Then by putting the tile on here, we can sort of use the end of the tile or close to the end of the tile so we can get a few pieces off each one. So you need to do 4 little dots, and then we cut the tile on those 2 angles. And as you can see, that's already got that slight segmented shape. It's splayed back. Number it. Cut another one for us, Reece. Thanks very much. We say ages, but it's not. An hour. We'll take the edge off them with a bit of sandpaper, just to not have that little bird edge lipping sort of effect.
And so have we ended up with our 2 mil that we were chasing?
Pretty much.
Pretty much?
Yeah, you'd have to say that's fairly close to 2 mil. That is just done quickly. It's I'd say you're pretty close to 2 mil. This is yours, by the way.
Yeah, that's all right. It's good.
I never leave pins lying around. Okay, could you clamp that down for us? Thanks. Just at one end. Okay, we're going to produce that line through there. Okay, having produced a square line, now this is optional. You can do this first or after. It doesn't really matter. Oops. And basically we're just going to lay out our tiles there with our 2 mil joints. Okay, who wants to help me lay some tiles out here, guys? Keeping that perfectly square through there.
Guys, what are we working with here? Is this a 200 mil tile?
200 by 200, yeah.
Okay. And we're going to go 4 by 4 inch, like.
Yeah, we'll go 4 by 4. That gap's the same to that other side. Yep, pretty similar.
Okay. What I've done there is very similar to what we've done. So now I think we might have some success here.
And when you do diagonal spacing, you need to actually put that tile in there to let you know how far that gets spaced apart. Because you can't tell diagonally how much the joint's going to be unless you put the one next to it like that, and that determines how far apart they are.
If you stick with that diameter of 720 on your outside circuit, you're still well within the parameters of your 810, 815, and you're going to get a nice looking inset with your smaller tiles.
So there's the
Professionals.
We don't need to talk
You mark them and pass them.
Hey?
Mark them and pass them.
Lines out.
We did that one there on the board.
And 0, 0.
Yeah, so we come back to 200.
Yep, brings it back.
Yep.
That's it. That's the way it works.
Both ways.
So it's all it comes through the 1.4.
Yeah, it has a little bearing unless you start doing a lot of intricate test-loaded work.
Yep.
Heavy federation work.
Yep.
You start to need to sort of work that out.
You'll need it. It's a great formula. It's so simple. It's
Quicken things up a bit.
And I always prefer to quote off a plan than have to run around running tape measures.
That's it.
It's, you know, it's
a
just
waste of
inconvenient,
time.
isn't it?
Yeah.
So yeah, that's right. That's worked out spot on.
Well, Jordan, how are you working out the tiles?
okay. For what area?
Like inside here.
Inside. Okay. So how many tiles you actually need for the inlay?
Yeah, how would you work it out?
Well, probably your simplest way to go with your inlay is, being relatively small, is probably just your number of tiles. If you've got 4 wide, by 4 wide, basically you're going to end up with 16 straight off. Obviously you can convert that to square metres if you need to. And there's going to be, how many 200 mil tiles can I sit along 1 metre?
5.
Exactly. So that'll give us 5 along that direction, and obviously the same there.
Yep.
And straight away you can tell me how many you're going to have for that square metre.
Yep, 25.
Exactly.
Yeah.
Yeah. So you've done an instant calculation there as to how many you will use, how many tiles per square metre, and how many tiles you'll need for the job itself.